These are the last two problems from day 3 of the inverse problems. So, what does this thing look like?
What do you mean?
Is it a straight line? It's a rocket. If you put this in your calculator, you'll see the rocket, like that. And that's okay. Can you give me the ordered pairs that you see on your table? Mr. Duke, can you grab a calculator and do that? Does anyone know what the very first ordered pair is? -6, 0. -5, 1. Thank you. -2, 2.
Where do you get? Oh, you grab these? Yeah. Where do you get these numbers?
Where are we getting them? Cassidy, where are you getting them at?
I'm just plugging in the numbers.
She plugged numbers in here. -6 plus 6 is 0, the square root of 0 is 0. -5 plus 6 is 1, the square root of 1 is 1.
Okay.
-2 plus 6 is 4, the square root of 4 is 2. And -3, wait, how'd you get this one?
I think it's 3 and 3.
Did you-
It is.
I'm sorry, I wrote it wrong. 3, 3. This is a positive 3, 3. If you plug 3 in here, you get 9. Square root of 9 is 3. Now, Cassidy did you just pull the numbers? You just thought about it?
Yeah.
Okay, now if you're not able to do that, you were able to use your graphing calculator on this. You type in the equation and Control-T will give you your table. Okay? So what does this thing look like if you graph it? It's a rocket.
I thought you just had like
Here are the ordered pairs. Okay. So this in orange is the graph f of x. Now, can you give me the inverse ordered pairs? What are they?
0, -6. 1, -5. 2, -2. 3, 3.
Okay, can we graph these?
Yes.
0, -6, I'm gonna do them in blue. 0, -6, 1, -5, 2, -2, and 3, 3. So now this looks like this. And that's the inverse one. So now we need to finish this up. I need to make sure you understand what the equation is of this. Okay? But before we do the equation, let's do the domain in the range of the orange graph, the original. The domain is the x values. This is your x-axis right here. What x values does this orange graph represent?
X is greater or equal to -6.
Very good. X is greater than or equal to -6. Beautiful. How about the y values? What's the smallest y value?
0.
0. So y is greater than or equal to 0. Now when you do the domain in the range of the inverse, what happens?
Flips.
They switch, because that's what you're doing. You're switching your x and y.
X is
So
greater.
what you have here is x is going to be greater than or equal to 0,
Can I ask you a question?
and y is going to be greater than or equal to -6. Yeah,
When is it all real numbers?
is the parabolas. In the, you mean for the domain?
For-
In the linear ones.
Mhm. Yeah,
Linear
yeah,
ones is all
okay.
numbers.
I should've been.
Now, can you give me the equation? How do you do the inverse relation of the equation? So you have,
Switch the signs.
right now you have y equals the square root of x plus 6. What are you gonna do now?
X equals square root of y plus 6, and then you square both sides.
Okay, square both sides. Now I'm gonna write this like I've been doing. You're gonna square both sides. So y plus 6 equals x squared, and then subtract 6. Now, this is a parabola. It is half of this right here, this blue. If I were to graph this x squared minus 6, it would be this part here too. But by writing this restriction here, This stops us from using this portion of the parabola. So here is the inverse relation, but these are the stipulations that we only want out of this equation. We only want the x values that are greater than or equal to 0. Now, does that make sense? Look at the blue. Here's 0. Are we only using the x values that are greater than 0? Yes. And the y values are greater than or equal to -6, and that makes sense. Now, for this one, you can write f -1 of x. The one you can't write f -1 of x is the parabolas, because they're on their side and they don't pass the vertical line test. But this is a function. You can use this, but you want to make sure you have this correct. And then the last one, and then I'm going to let you guys work. How do you graph f of x is equal to x minus 4 squared? Well, if you remember from,
Or it's not a graph or how to solve it.
well, I want to graph it. First of all, you need to know that it's a U. I need the vertex. The vertex is going to be 4, 0. And if you plot this in your calculator, Mr. Du, these are the ordered pairs that you should get. Okay?
And I don't
You
think
should
that
get-
would fit.
Wait,
And that's not.
I can't see it. Okay, there, I got it. And then my glasses on. Okay, so 4, 0 is your vertex. And then, I told you guys, I don't know if you remember this, look for that pattern. So here's that pattern. See how these two are repeating and these two are repeating? This is your vertex. I want the vertex and I want 2 spots before and after that vertex. So here it is right here.
What does the last one say?
Huh? 4. 4. See it? 6, 4. So what are your 5 ordered pairs that I want? 4, 0 is your vertex. I want 3, 1 and 5, 1.
2, 4, 6.
And I want 2, 4 and 6, 4. Now, can you give me the domain and the range of this function? We'll put it in orange like we've been doing. And it is a function, right? The way it is right now, it's a function. This is f of x. It's a function. We can call it f of x. Can you tell me what the domain is? What x values can you plug in here? All real numbers. But what y values appear?
All greater than 0.
Greater than 0. Y is greater than or equal to 0. Okay, now let's do you want to do the points first or you want to do the equation?
Like, you go-
Points.
Oh, they're all, okay, so how come these are all real numbers? I thought you said they're for line.
All real numbers is the domain for parabolas because the domain is the x values. They're asking you, what x values can you plug into this equation? And you can do any of them. Look, any x value can be put into that equation. But what comes out are only numbers that are greater than or equal to 0. So now let's flip these points. 2, 4 gets flipped. 1, 3, 0, 4, 1, 5, and 4, 6. Now, why is this not a function? Why is this inverse not a function? The x value repeats, correct? Let's see what it looks like. So 0, 4 is our vertex. We have 1, 3 and 1, 5. And we have 4, 6. And So is this blue graph a function? No, it doesn't pass the vertical line test, and I've got these x values that are repeating. It's not a function. So when you do the inverse relation, do not write f negative, this is the only one that you do not write f negative 1 of x. But let's see what the equation, what this equation's name is. We have to name it. This equation in orange is called f of x is equal to x minus 4 squared. This blue one has a name. We can't just say, there it is. It's got a name. Let's name it. So how do you do this? How do you find the inverse relation? What do you do with your x and y? So this is what you have. You have y is equal to x minus 4 squared. What are you going to do?
X equals square
Okay.
root both sides.
Now, I like my y value to be on the left side. Now I'm going to square root both sides because I need to get to that y value. So you've got y minus 4.
Wait, what did you, I'm confused, what did you do?
I switched x and y around,
Yeah,
okay? But then I rewrite it because I like my y value on the left side.
I thought you were,
Resolving it for
what I
y.
did was I foiled, so I didn't know if I
No.
was.
And now bring 4 to the other side. Now, it's not a function, so don't replace this y for f negative 1 of x. This is this equation right here. That's the name of this in blue. Now, we have to state the domain and the range. What's the domain gonna be? X is gonna be greater than or equal to 0, and your range is gonna be all real numbers. These just get switched. And that's it.
We're done.
Yes. You can
Why?
stop, Travis, we're
Can I
done.
ask you a question?